Brad Williams, Frugal Finance. Let's continue. We have continuous cash flows as opposed to discrete. As I pointed out, discrete, you put in, say, an annual contribution into something. You invest in it on an annual basis. Discrete, but in terms of continuous flows means that instead of money coming in all at once at specific time, it comes in little by little throughout a period, like money flowing into your bank account steadily instead of in one lump sum. In other words, look at it in terms of an annuity. If you're receiving an annuity, you receive some type of compensation every 2 weeks. Okay, a paycheck. That would be sort of a continuous cash flow. To make this easier to calculate, we pretend that the money flows in evenly and smoothly over time. So if you're expecting $1,000 to come in over a year instead of getting it all at once, you might get a small part of it every month, as I just explained. Now, let's say you want to figure out how much $10,000 that you receive every year for 10 years would be worth today, with an interest rate of 20% that's compounded continuously. This means that the money keeps growing at a steady rate, not just once a year. I've said this repeatedly. That's why it's called compounding. The present value of this continuous cash flow would be $43,233. This is the amount you'd need to have today to have the same value as receiving $10,000 every year for the next 10 years, considering the interest rate. Frugal Finance. This is all about power of compounding. How easily we just don't recognize how powerful this tool is. Think about it. You put in $43,000 today, 43. This 43,000 will grow to that level based on, 20% interest. That's a heck of a return, but you kind of get the idea here. It's sort of just free money. That's why Wall Street is as wealthy as it is, because somebody's paying this rate. The finance guys are just laughing and smoking their cigars and doing whatever debauchery that they're doing. And it's sort of free because it really is no work. If you're receiving this, you're not doing too much work. Sort of like if you invest in Treasury. The government's doing all the work and you're sitting fat and happy because you're receiving that interest. So somebody's paying for it. So the American, with the deficit we have right now, no one seemingly is paying this, but you get the point that finance is all about free money. Frugal Finance, recognize that. I say free money. If you're an expert and you understand all these formulas, you know it's not that terribly difficult to incorporate this into your operations. Not a lot of backbreaking work in order to do some simple math. On the other hand, if you want to know how much those same 10,000 annual contributions will be worth in the future after 10 years, given the same 20% continuous compounding rate, it would be $319,453. I said your contributions would be $100,000, but the growth is $319,000. Not bad, huh? Not bad for sitting on your yacht. That's the objective here. Yeah, I don't have a problem with you guys going out and buying a yacht if you know how to do this. So far, only discrete cash flows have been assumed. It's assumed cash flows occur at the end of the year. In some cases, money is expected throughout the year on somewhat consistent basis. Cost of labor, blah, blah, blah. To demonstrate the continuous flow model, let's say you're able to divide 1,000 into K equal amounts to be deposited at equally spaced intervals in time during the interest period. So we're using 1,000. This is what we're working with right here. You can decipher this on your own if you're an engineer and you want to do it that way. But as finance guys, we like to see the actual data. We've used this formula before. The notation is sort of quirky, but just go with it. You can change it to whatever letters you want, which reduces to this right here. And taking the limit, what's the limit? It's not the Eagles singing their song, taking it to the limit one more time. Taking the limit of P as K approaches infinity gives this number. In other words, this is continuous compounding. We're going to replace this limit to EXP. And I discussed this earlier. How does this work? Well, open up your algebra book. It's simple math. We're looking at this garbage here, this notation, which is not mine. Clearly, I would not have this in here because it's confusing. But look, some of you might be using these other equations. This right here doesn't do anything for me. But with that being said, we have P of A, or is referred to as continuous compounding uniform series. with continuous flows and continuous compounding, remember it's continuous flow, that would be that $1,000 on a either daily, weekly, monthly basis, continuous. And we have this continuous compounding, similar to the previous example. The continuous annual cash flow is equivalent to this formula here when discrete flow and continuous compounding is used. We're combining apples and oranges. Can you do that? Well, of course. What is the present value of 10 grand with annual contributions per year for 10 years, earning 20% continuous compounding? We just did this. But we'll do it again. EXP 1, 1, 10, 2, 1. So what are we doing here? We're going to look up at the 432. This is what we're doing right here. EXP 1, 1. Remember, we're using this formula. So we have 1, 20, 10, minus, and then we're going to go through this final calculation. What's the math here? Again, we have this growth factor. All we're trying to do is find this factor, and then all we're doing is multiplying it. Don't let these formulas intimidate you. All we're doing is compounding. We're looking at the future value here. What's this 10 grand? 43,000. This is discounted. All we're doing is taking this number here. This is, it's 432, is this documentation right here. Plug and chug if you need to. If your computer blows up on you, you're going to need a substitute. Well, here's the substitute. This is old school. This is reality is what it is. All you're going to do is just determine this factor. This is the annuity factor. And then if we want to look at the future value, the factor is 31.95 with some, keep in mind, there could be some rounding issues. So we have 319,453 with 319. Okay, we're doing everything correct. We're following all the formulas and we come up with this number and it agrees with the normal computation. So now here's the puzzle. If we map this thing out, and here's a map, and we're going to look at the future value of this 20% compounded daily over 10 years, starting with 10 grand. Why is this 352 as opposed to this 319? Think about it. And then reconcile this thing. This right here is just a rounding error. This is with daily compounding. This is with annual compounding. But the numbers don't reconcile to this 319. Tell me why. Is it a rounding error? Tell me what it is. Brad Williams, Frugal Finance. Thanks for watching.